Now we're going to see an application of reading a file. When I teach programming courses, this is one of my favorite parts of the course because now we can work with more realistic amounts of data. Up till now, we were largely restricted to hard coding values within our programs, which limited how much we could put in there, or at least how much I would reasonably expect to hard code into a program. Therefore, some of the things we did up to now weren't entirely realistic, but the purpose of those other programs was to learn some basic concepts. Now we can start to pull things together and do some things that are more realistic in nature. So here's a problem I actually had to deal with a couple months ago. It was time to choose a new electrical plan for my home. And my electrical provider gave me two options. Plan 1 charges you about 8.8 cents per kilowatt hour during the daytime, where they define the daytime to be 8 a.m. to less than 8 p.m. And they charge about 7.8 cents per kilowatt hour for nighttime, where that's defined to be 8 p.m. to less than 8 a.m. There's also a delivery cost that's included, which has a flat amount of 3.42 or $3.42, that is, plus about 3.5 cents per kilowatt hour. Plan 2 charges the same amount per kilowatt hour regardless of the time of day, and that amount is about 7.8 cents. And the delivery costs here are the same as they are for the other plan. One of the things to note about the delivery cost is that the $3.42 is charged no matter what you do. So even if I use no electricity, I'm still going to pay $3.42 just for having the ability to use electricity. So I'd like to write a program that, given some actual electrical usage data, can determine what the cost would be for that data given this plan and the cost given this plan, so that way I can see which one would really be cheaper. So to do that, I downloaded some data from my electric company. So I have what's called a smart meter. So they read the meter remotely in increments of 15 minutes. So here's the actual data for that. So I downloaded this for the time period January 1st, 2020 to May 31st, 2020. And you can see this file has over 14,000 lines. So trying to do something with this by hand would obviously be unreasonable. Let's go back up to the top and see what we're dealing with. So here's the first line of the file, and that's what we call header line. And the file itself is in a format called comma separated values, or CSV, and they have the extension CSV. It's fairly common, and one of the benefits of it is that it's all stored technically in plain text. So I could open this up with any text editor or programming editor. Each line represents a 15-minute period. So if we jump over here to this right here, it shows for the first 15 minutes of January 1st. Here's from midnight until 15 minutes later, and then 15 minutes after the hour to 30 minutes, and so forth. And it continues on for the rest of the day, and then continues the same type of thing for each other day. Let's zoom in on this and look at this. So here I've reformatted it. So here we have these two lines, which are the first two lines of the file, and I've reformatted to make it easier to read. So you can see the first thing I have here is the ID number for my meter. That's the only thing in this file that's not technically correct. I replaced the actual ID number with this bogus number since it is the ID number for my meter. But everything else is real. So you can see here it says usage date was January 1st. There's this revision date, and I'm not sure what its purpose is. The start and stop time period that they're looking at for this line in the data file is from time 0 to 15 minutes into the hour. So the 00, this is the initial time, so this really means midnight to 12:15 in the morning. And for that time period, I use 0.043 kilowatt hours. And then you have two additional fields that I don't actually need. So for problems like this, I typically start off by looking at the data. The reason for that is, one, to find out if it's even feasible to do what I want. Maybe there's not information here that I can use. Or I look at it to basically understand the problem better. Because if I don't understand the problem myself, how do I write a program to solve the problem? So how would I actually do this if I was doing it by hand? If we go back and look at the data, right, look at the data file, I could take plan 1 and say, okay, for this time period, calculate the cost, figure out which time of the day it is. So this is nighttime cost, so I'd use the appropriate cost per kilowatt hour here, and then do the same type of thing here, then here, then here, and so forth. And then when I got to daytime cost, switch to the other dollar amount, and so forth. And then I could repeat that using plan 2. So I understand what the process is. It's just that there's too many numbers here for me to deal with by hand. If I only had to look at 1 hour, for example, well, then it wouldn't be that difficult to do each of them by hand and then compare the two costs. But I do have, 4 times 24 lines per day. So then I go to the step of trying to understand the process, and for that I wrote pseudocode. So my pseudocode for the process is I start off by opening up the file. Then for each line of the file, I want to do this. Get the date, the time, and the kilowatt hours per line. What's the purpose of that? Well, I'm going to look at a particular month because I thought it was representative of the future. And in this case, it would be May. So I want to get the date so I can determine if the month or the date I'm looking at is in May. And I also need the time and the kilowatt hours. The kilowatt hours is needed for both plans, obviously, to determine the cost, but the time is needed for plan 1 since I pay a different amount for different times of the day. Then I'm going to ask a question. Is the date that I'm looking at in the range that I'm interested in? If not, then I move on to the next line anyway. But if it is, then I need to do a couple things. For plan 1, I need to use the time to determine which cost to use. If it's daytime, use that cost. If it's nighttime, use a different cost. For plan 2, I just use the kilowatt hours regardless. And then after I've done all this, I'll remember to close the file. So this is my pseudocode. So as we look at the actual program, which took about an hour to write, which is why I'm not showing you the development of it. I'm instead talking about it. But it took about an hour to do, so I'm going to show you the final product and we'll explain some of the rationale behind the decision making in that. So let's start at the top. So since I typed up my pseudocode, I like to actually include that in my program as a comment, because if I revisit this program later, it's much easier for me to read the pseudocode and understand the big picture than it is to look at the logic. And I think it's easier for you to probably look at this and understand what I need to do, as opposed to looking at for loops and if statements and that type of thing. I end up writing 3 functions to segregate the functionality. But let's look at main first. So I'm going to have a file pointer for opening up the file, the name of the file to read, which we looked at over here, a buffer to store 1 line of the file, because I like to use fgetString when I'm reading files in most cases, the month as a string that I want to look at. Since there's 5 months inside this data, I need to compare each date stamp to this month, so I'm looking at the appropriate monthly cost. Here's 2 things that I need to fill in. So when I get a line from the file, remember I said I need to know the time of day that cost is for, so plan 1 can use it, but I also need the kilowatt hours. So I'm going to populate these 2 variables with the appropriate values for each line. Date match is something I use to determine if it's a match for the month I'm interested in or not. So basically it holds a true-false value. And then these will be the cost for each plan. So as I read a line, I want to update the cost, right? So I start at midnight and both of these will get updated. Then I add in the next 15 minutes and both of these will be updated. So why put 3.42 here as an initial value instead of using just 0? Well, remember I said that no matter how much electricity I use, I still have to pay a flat fee of $3.42 for both plans. So I use that as my initial value for the total cost, and then as I read each usage of kilowatt hours, I just add that to it. So that's why that's there. And I include a comment here so somebody reading the code understand what its purpose is. Because otherwise you might look at it and think, so where does he come up with 3.42 from? That's the reason for it. Look at how the pseudocode, or excuse me, how my logic matches my pseudocode. Going back up and looking at it again. Open file. For each line of file, get the date, time, and kilowatt hours. If the date's in the appropriate range, update the cost, close the file. Open the file. For each line of the file, get the date, time, and kilowatt hours. If the date's in the appropriate range, update the cost, and then eventually close the file. So this matches pretty closely with my pseudocode. And then it was just a matter of turning the pseudocode into the appropriate logic. But by breaking it up into those steps, it's much easier to work with. It turned out that writing check date, which is the part that tokenizes the lines, is where I spent the vast majority of my time. So we'll look at that here in a moment. But notice also, once this is all done, then at the end of main, I just print out the two sets of cost. And while we're here, we'll look at that and see that the two costs for May worked out to be, based on those electrical those two plans and that actual usage. If I'd been on those two plans already, the cost would have been $63.50 or $60.50. So it looks like for that month, plan 2 would have been a better option. So now let's look at check date. So what does it receive? Well, it receives a line from the file and the month that I'm interested in looking at, but it also receives these two variables, which are going to store the time of a particular line, as well, or the time of day, as well as the amount of kilowatt hours on that. But these variables are here because I need some way basically to send them back to here so I can pass them on to the functions for calculating the cost per plan. I need some way of sending them back, and this is the way I do it. So since T is an array, I just populate that array because I'm technically passing the address anyway. But for kilowatt hours, which is right here, it's a double. I pass in the address of that right here, and then I'm going to populate that address with the actual kilowatt hours on that line of the data file. So that's the way I send information back for these two things. I'm also returning this int right here is the actual return type of the function, and that's going to be a value that's considered true or false, so that way I can decide, do I update the plans because it is in May, or don't update the plans. Here's the data we looked at before. I like to also include stuff like this in a program because when I come back to work on the program, if I need to debug or add some functionality or whatever, lots of times I can't remember what the parts were. So by including an actual couple of lines from the file, and this makes it even easier to read, by including the actual data, I can look at it and say, oh yeah, this is the field that means whatever, and this field means something else, as opposed to just looking at it and saying token, 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 which is what you see here. All right? So let's see how the tokenization worked. So we get this line right here. I need to extract the date so I can check to see if it's in May. I need the time of day that usage is for, and I need the kilowatt hours for that time period. So I'm going to do a bunch of calls to string toke. So I call it the first time and I get the meter ID, but I don't actually need that. I just need to move past it, so I throw that away. And I put a comment in here that that's the reason I'm overriding token right here, because I don't need to use it. Then when I call string toke again, I get the date that I need to check. Now at this point, technically I could tokenize the date to see if it's May, but if you've seen my video on using the string library functions, you'll know that string toke is not very robust. If I tokenize that field looking for the month, well then I won't be able to pick back up on the original parts of the line. So instead I'm going to save the time field that includes the month, the day, and the year. I'm going to save that date. That's actually what is a date, not a time field. Save that into this array, and later on I'll tokenize it. So then I continue on. There's the revision date. Throw it away. I don't need it. Start time. I don't need it actually here. I need it back in the place where I'm going to calculate the cost. So I copy it over to that time array that we passed in. Then we'll call string toke again to get the end time. I don't need that, so I'll throw it away. And then finally, I'm going to call string toke one more time to get the kilowatt hours. Well, even though when I look at it, it looks like a number, it's really a string. So I'm going to use A to F to convert that string to a floating point number, and I assign it to the address that I passed in for that double. So this puts it at the address stored in KWH. There were two other fields on that line, but I don't need those, so I don't waste my time processing them. Now that I've made it through the entire line, getting the three parts I need, now I need to figure out if it's the month that I'm interested in. So I'm ready to tokenize again. So this time I tell it to tokenize date field, looking for the slash as the delimiter. When I find that, now I'm going to compare that month, which consists of 2 digits, all the way from 0, 1 up to 1, 2 for December. I'm comparing that to what was passed in. If they're equal, I get 0, so I return 1 to indicate true. Otherwise, I return 0 to indicate false. So now when we go back up, we can see right here, that'd be date match. And then I say if date match, update the cost for plan 1, plan 2. Now technically, I could have just taken this function call and embedded it right here. That would have been fine too. But I think this makes it a little easier to read, so I've done that. But it really makes no difference in the long run. So now let's look at cost plan 1, which needs the time as well as the kilowatt hours. So that somebody understands where these numbers came from, I've included the actual cost that I got from the electric company here as a comment. And then it basically came down to checking to see if it's daytime, which means greater than or equal to 8 a.m., but less than 8 p.m. If so, use this cost for the hour, for the cost per hour plus the fixed cost amount of this per kilowatt hour. Otherwise, it's nighttime, so use this cost per kilowatt hour at night plus the fixed cost amount of this per kilowatt hour. One of the things that's nice about the data is that the person who created it was smart enough to use military time. It's much easier to see if the time is greater than 8 or greater than or equal to 8 but less than 20 than it would be to see if it's greater than 8 a.m. but less than 8 p.m., which is technically what this represents. Because now I've got to look at the a.m. and the p.m. and figure that out. It saves yourself a lot of trouble, or you save yourself a lot of trouble if you do something like this. And also in terms of sorting it, it's just easier with this. All right, so think about that if you're in the data generation process. While we're here, let's look at cost 2. Not a lot to that. Here's the cost per hour that I'm paying, 7.8 cents per hour, plus the part of the delivery cost per kilowatt hour that's right here. So there's not much here, so why even create a function for it? Well, one, I think it improves the readability of the code, because then I can look at it and just see that I'm calling the function for produce cost for plan 1 and cost for plan 2. But also, if the way that I performed the cost was a lot more complex process, then I could have a lot of lines of code here and it would make more sense as well. Of course, this is one line of code that could easily have been included up the top, but this is 4 lines of code to try to figure out what I'm doing. So I prefer just to do this. Check to see if it's in the appropriate date range, and then call a function and call another function. Once again, it's about readability, and I've tried to make the code match very closely with my pseudocode. All right, so there's the entire process. Hopefully it helps you understand how to think about writing a program like this, and it really helps to sit down and work things out, and also think about the data management process. I will tell you, as I said earlier, the part of the program that took the most work was this right here. And what you don't see, because I've already produced it, is as I was working on this, I put a bunch of print statements in here to make sure I was actually tokenizing it correctly to get what I need. Because I don't know how many times somebody has asked me for help with a program that, say, had 5 steps, and step 2 was this, processing the data in some way. Well, when they were looking at their logic, they thought the problem was with step 4. But then when I looked at their code, I realized there was no problem with the logic in step 4. The problem was what they thought they had produced in step 2 was wrong, so therefore step 4 couldn't work correctly. So it's much better to check things as you go along. And so once I got all this working, then I moved on to writing the other functions and doing the other things. But if you don't have the right data, it doesn't matter about the rest of the logic. It can't work correctly. So think about those things as you do your own development.